Okay, so today, Common Core Standard, what I want to talk about today is rational equations solving rate and work problems. Okay, please hang on to these notes, you guys, because this next test is going to have one of each of these problems on it, and you're going to do so well on it because you're going to say, I'm kind of confused, but hey, I got my notes. Pull your notes out. Bam, I got it, okay? All right, so first of all, let's just read it. A kayaker spends an afternoon paddling on a river. She travels 3 miles upstream and 3 miles downstream in 4 hours. In still water, the kayaker averages about 2 miles per hour. What is the speed of the current? Okay, so let's check. You know the distance is equal to rate times time. We know that, okay? That's a formula you guys know that you never even think about, but you know that if you're going to get in the car and drive 60 miles an hour for 3 hours, you've gone 180 miles. I mean, you guys know that, right? This is a formula that every time we put up in physics or in math, kids are like, what? And then you start talking about, oh yeah, you guys use this formula all the time, don't you? Right? Like, so you drive 80 miles an hour for 2 hours. How far are you going? 160 miles, right? You know this problem. Yes, Savannah. I'm doing the back first. Yeah, I'm doing the back first. So what I want to do is set up a little chart. So we're going to have distance, rate, and time, but I'm going to do a chart because I'm going to have two things going on, okay? We're going to have upstream, and we'll go downstream, okay? The chart really helps. So what do we know? She's going to go 3 miles upstream and 3 miles downstream. So the distance is 3. No variables, just plain old 3. You guys agree? We paddleboard up 3 miles. So we're going to go from maybe Blackbird, and we're going up to maybe the hatchery, okay? And then we're going to turn around and go from the hatchery down to Blackbird. So the distance is the same, right? Now the rate. You've got the current, and either the current's going to help you or hurt you, okay? So if we can average 2 miles per hour, then upstream, we're going to have our 2 miles per hour minus the current, because the current's going to slow us down, right? And downstream, we're going to have our 2 miles per hour plus our current. So we're just going to be paddling along, just chilling, right? And that's our average rate, okay? The time it takes, though, is we're not sure what the time is, but it'd be nice if we knew the time, but we do know this, that if we take a look at this formula right here, that we can solve for t and have it as t is equal to, if I divide, right, by r, divide by r, distance divided by the rate, okay? So that is one value for time, because we don't know anything about time. I mean, all we know is we're out on the river having a good old time. How long did it take us? We don't know. But we had a good time, right? So our time then could be described as 3 over 2 minus c and 3 over 2 plus c, okay? Because I'm going to use this formula. So this formula is just the distance over the rate. The distance over the rate. Now, here's what we know. Okay, the distance down and the distance up is the same. You guys agree with that? So what I'm going to do is I can set them equal, okay? The distance, so the distances are equal, right? So I can set it equal, okay? So I'm going to go ahead and, oh, wait a minute. Am I missing something here? Oh, 4 hours. My bad. I do know time. Okay, the down and back is 4 hours. So let's do our distance up, which is our 3 over 2 minus c, plus our distance down, which is our 3 over 2 minus 2 plus c, equals our total time of 4. So everything in terms of time. Time 1 up, time 2 down, equals a total time of 4 hours, okay? All right, now I got to solve for this darn thing, right? How about a common denominator, okay? Okay, what do you think about a common denominator here, okay? Remember how we did the common denominator? What does this fraction have that this one needs? And vice versa, what does this fraction have that this one needs? Well, this fraction's got a 2 minus c, so I'm going to give it a 2 minus c over a 2 minus c. And this fraction needs a 2 plus c over a 2 plus c, okay? Alright, now let's see if I can simplify this. If I go ahead and I would have my common denominator, which is my 2 plus c over my 2 minus c. And on top, if I just do a little distribution, I have a 6 plus a 3c plus a 6 minus a 3c equals 4. Okay, how am I doing? I'm running out of room. Shoot, I'm running out of room. I'll just have to squeeze it in, huh? So, my c's cancel, right? Am I going too fast? And I'm left with a 12 over 2 plus c, 2 minus c equals 4. Okay, am I going too fast? So whenever I get a fraction equal to fraction, what I did in geometry is we cross multiply. Remember that? In geometry, if we had a fraction equal to a fraction, we just cross multiply. So I'm just going to cross multiply. I'm going to bring that up there and bring that up there, okay? So we'll cross multiply to have a 12. I'll squeeze it in over here. We'll do this on a separate sheet of paper. A 12 equals a 4 times a 2 plus c over a 2 minus c, okay? Well, I got some work to do, but I can do that. So I'm going to first FOIL this, but that's easy to FOIL, right? I'm going to just FOIL this, and that does FOIL into a 4 minus c squared. If I FOIL it, because the inside, I get the negative 2c and positive 2c cancel, equals 12, okay? Now, you could multiply through the 4, right? Or you could do what? Let's just divide by 4. It makes it easier, okay? So with that, you okay with that? So if I just divide by 4, it's so much easier. It saves me time. You okay with divide by 4? Divide by 4. It'd be easier to multiply it through, so divide by 4. So I get 3 equals 4 minus c squared. Minus 4, minus 4. How am I doing? I got negative 1 equals negative c squared. Divide by negative and get rid of the negative, so I got 1 equals c squared. You okay with just getting rid of the negative? Just basically divided by the negative, got rid of it. Square root it, right? And what's the square root of 1?
1.
It is 1. And negative 1, but negative 1 wouldn't make any sense. You can have a negative current. That I'd like to see. Right? Yeah. So then the current is just 1 mile per hour. Okay? Now I totally ran out of room to do example 6, but I'll just do example 6 on a separate sheet of paper, okay? Do you guys want to get a separate sheet of paper out?
I
Do you have room? Okay, good. I wrote way too big. I'm going to have to, fourth period, squish this over and do my work over here, aren't I? You guys are always my guinea pigs every morning. Did you know that? Whatever mistakes I make with you guys, I remember for fourth period, so. Okay, I'm going to do the work problem on a separate sheet of paper, okay? All right, work problem. Example 6. Jason can clean a large tank and an aquarium in about 6 hours, okay? He can do one job in 6 hours. When Jason and Lacey work together, they can clean the tanks in 3.5 hours. That's the total time. How long will it take them to clean, Lacey to clean one tank by herself? So here's how it works, okay? So, on a work problem, well, that's no good. On a work problem, we're going to do this. We're going to set up one job. Okay, so let's do Jason and Lacey together they can do one job, okay? They're only going to clean one tank. They're not going to clean 2 tanks, and if that's the case, we just double our answer, okay? Or triple our answer. So, Jason can do the one job, right? He can do one job all by himself in 6 hours, okay? Lacey by herself, we don't know. She can do the one job in, we'll say 8 hours, because we don't know how long it takes for her to do it at all by herself. That's what we want to find out. But Jason can do the one job in 6. With Lacey, she can do it in however many hours. We don't know. But together they can do the job. They can do one job. Now, together, though, they can do the job in, is it 3.5 hours? Yep. So they can, together, they can do the job in 3.5 hours. Okay? So let's see what we got. Jason can do the one job in 6 hours. Lacey can do the one job in I don't know how many hours. Together they can do it in 3.5 hours to do the one job. Okay, now let's go ahead and simplify this. This is going to be a 3.5 over 6 plus 3.5 over h equals 1. How am I doing? Well, I think I can do this problem without a whole lot of work. I don't think that's going to be too bad. What is 3.5 divided by 6? I don't know. That's what I'm going to use my calculator for. I mean, you may as well do that, right? You guys agree? Let's make this number easier. So 3.5 divided by 6 is about 0.583 repeating. Okay, I just divided that. You okay with that? Just divided that. And then I'm going to solve, so let's just subtract this from both sides. Minus 0.583 minus 0.583. Okay, I'm just solving. So that's gone. I have a 3.5h equals, let's see, what is this? 1 minus that answer. I get about a 0.416 repeating, okay? Cross multiply, right? So I can bring the h up here. Okay, bring the h up here. Cross multiply, right? Think about that as over 1. Cross multiply. So I have 3.5 equals. If I bring that up at 0.416 repeating h, almost there. Divide 0.416. Okay, so what's 3.5 divided by that? And I'm going to get an answer of 8.4. Alright, got it. So what does 8.4 mean? That's the time it takes for Lacey. So Jason can do it in 6 hours. Jason can do it in 6 hours. Lacey can do it in 8.4. But if they do it together, it takes them 3.5. Does that make sense? Okay, one more time. Jason can do it in 6 by herself. Lacey can do it in 8.5, 4 by herself. But together they can do it in 3.5, okay? So these work problems set up the same way always, okay? You'll have, on your last test, you'll have these 2 story problems, okay? You can do them. Just keep your notes and set up the same, okay? All right, now let's take a look at the front, okay? The front of this, all right? Solve for x. So here's our goal. Here's our goal. Our goal is to solve rational equations and the way we did it in the front was we got a common denominator first. So our goal is to get a common denominator, and then cross multiply, okay? Okay, so let's see. Let's check this out. So my goal is to get a common denominator and cross multiply, okay? So this is an x over 1. All right. Well, how can we get that we need a common denominator of 1x, don't we? I mean, to make these the same, I've got to have a common denominator of 1x. So I need to give this first fraction an x to make it an x on the bottom. So to get a common denominator, I'm going to multiply this one by x over x. Let's see how that helps me, okay? So I'm going to get an x squared over an x plus a 8 over an x equals 6. How am I doing? Okay, just need a common denominator. So this one had an x, this one didn't, so I gave it an x. Now they have the common denominator, so I'll make an x squared plus 8 over x equals 6, okay? Six over 1, right? If I cross multiply, that times that equals that times that, I'll have an x squared plus 8 equals a 6x. Oh, now it's looking like it's something I could do. I got rid of all the fractions, right? It's very doable. In fact, this thing might factor. You never know. It might factor, but I can't factor it until I bring over the 6x. Agreed? Got to get the 6x over. So I'm going to pick up the 6x, not literally pick it up, but I'm thinking, you know, why don't I put the 6x right there? How would I put the 6x right there? I'm going to have to subtract it, right? To bring the 6 over, I'm going to subtract it. So I'm going to subtract, get rid of the 6x by going minus 6x. I'll have an x squared minus a 6x plus an 8 equals 0, okay? This is the hardest chapter we do. Sorry, you guys. I saved it to the end. Didn't want to freak you out too early, huh? Now what? Let's factor, right? Boom, 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 boom. Running out of room, but x minus 2, x minus 4. You agree with that? And so then x will equal 2 and x will equal 4, okay? Sometimes you have to throw answers away because you make Cookie Monster sad. These answers are great. But if I go back to my original problem, if I had one of my answers was 0, I'd be in trouble. If x were 0, my original problem, I'd be in trouble, right? Because Cookie Monster would be sad, it'd be divided by 0. But these answers work, okay? All right. Example 2. Example 2 is easier. It really is, okay? So, I've got a fraction to a fraction, right? So, if we cross multiply, it works. But in this case, I got a little bit better trick. Instead of cross multiplying, let's multiply each side by x minus 3, x minus 3. X minus 3 over 1, x minus 3 over 1. Why would I want to do that? How is that going to... It's going to be a big help, actually. Why would I multiply both sides by x minus 3 over x minus 3? What is that going to do? It is kind of cross multiply, but what can happen next? Can I see some canceling? Hey, what happens if now that cancels that and that cancels that? So what are you left with? Emma, you're looking like, what did I do? So I thought, Emma, if I just multiply both sides by x minus 3, it would cancel it out, right? Let's go back to basic fractions, okay? Let's see, I had x over 4 equals x minus x plus 1 over 4, okay? So just think 4, okay? Just think 4. Forget, if I multiply both sides by 4 over 4, what's going to happen to the 4s? What's going to happen to the 4s? Boom, right? And boom, guess what? I did the exact same thing. And so if it's gone, guess what we got now? We've got this answer. We got an answer of 3x equals 2x plus 3. Easy squeezy, lemon peasy, you guys agree? What am I going to do now? Minus 2x, I get x equals 3, right? You guys agree with that answer? I don't. What's wrong with that answer? Simon, what's wrong? It's a bad answer. That answer is going to make Cookie Monster sad.
X minus 3 is on the bottom.
Hey, if x were 3, Cookie Monster's going to be sad. So, what's going to happen now? No solution. This one does not have no solution. No solution. So when you do fractions, you always have to be worried about dividing by 0. I'll say it again. Whenever you do any kind of fraction problem, always be worried about dividing by 0. Yeah, Leora?
I did this a little bit of a different way. So I saw that they have the same denominator already, so I got 1 over and just subtracted. And then you get x minus 3 over x minus 3 equals 0, and that's already a no solution.
Oh, nice. Clever idea. Yes, I'm not going to show that, but very clever. I like that. Okay, I'm not going to show it, though, okay? All right.
I don't think he likes it.
No, it's a great answer. I just don't want to, yeah. Okay, you ready? Example 3. Let's check out example 3, okay? I know, let's talk. You guys want me to stop here and just give the homework? No, we got time. We got time for a couple more. Okay, so you ready? Let's take a look at this. This fraction here needs a 2 over 2.
Why?
This fraction here needs an x minus 7 over an x minus 7, okay? This fraction here. So we can get a common denominator, okay? All right, so I can't zoom it in because I'm recording, but you ready? Ignore this part. Just look right here. Just look right here, okay? What does this fraction have that this one doesn't have? An x minus 7. What does this fraction have this one doesn't have? A 2. If you need a common denominator, they need both of them to be the same, right? So I gave this the 2 so they'd have the same, and I gave this one the x minus 7 so they'd have the same. So now they have the same denominator. That denominator is my 2 and x minus 7, okay? So we needed to make a common denominator. On the top, called the numerator, we'll have a 4x minus 18 plus an x squared minus a 7x equals a 5 times an x minus 7. These are hard, aren't they? No, I know. It's a good thing it's a Monday, huh? Okay. If I tidy this up, I'd have an x squared. Oops, wrong pen. I'd have an x squared. Come on, pen, work for me. Minus a 3x minus an 18, right? Okay, how am I doing? Alright, Emma KP, I'm going to make you frown again. How do I come up with this? I know I've been doing this for a long time, but think about this. If I were to multiply both sides by x minus 7, what happens? If I multiply both sides by x minus 7, what happens? Do the x minus 7's cancel, don't they? They just drop out. So multiply by. First of all, by the way, before I go too far, I better make sure this little disclaimer. Better make sure I say that x cannot equal 7, because if x does equal 7, Cookie Monster is going to be sad. You guys agree with that? So no matter what answer I get, if it's 7, I got to throw it away. Okay? You agree with that? So I am going to multiply by x minus 7, The x minus 7 is just canceled. Okay? Now let's see what I got. If I were to now cross multiply, you okay with that? If I cross multiply right here, I'm going to have x squared minus 3x minus 18 equals 10. Okay, I can probably do that, can't I? Alright, minus 10, x squared minus 3x minus 28 equals 0, right? Factor x minus 7, x plus 4, right? Do you agree with that? Solve x equals 7 and x equals negative 4. But we already said, what did we already say about this guy? You got to throw that one. So now we only have one answer. We at least have an answer, right, Megan? Okay, that's the 4. All right, I'll stop there because this one's very similar to the last one, okay? Because I don't want to kill you on this stuff, but I'd rather give you time to work. In fact, I'd be happy to do your homework with you today because you might need some help, okay? So here's our homework. It's on the back. It is page 605, and I'm probably today going to do your homework with you, okay? 19, 27 odd, and 28. Let me stop recording. And